Hello everyone, this is two sample z-test for difference in proportions and a little quick example so you know why. First of all, you'll start with the hypothesis, and we're usually given two proportions, population proportion, two proportions that we're trying to find if there's a significant difference between, so P1 minus P2 equals 0, so that's our null. Our alternative is P1 minus P2 greater than 0, not equal to 0, or less than 0, depending on what the context of the problem is. So quick conditions is it needs to be random, so either random assignment or sampling. Don't make the mistake of saying sampling when it's an experiment or assignment when it's a observational study. So assignment is experiment, sampling is random, is for observational studies. Each trial needs to be independent. So either that you can say that there's no effect on each other. So if I do this trial, it won't affect this trial, or 10% rule, which is saying that the amount of samples you have won't affect the entire proportion or chance that you pick someone. Basically, just another independence rule. So, and then the final is each sampling distribution is normal, and that is done through this. Is n1 times p hat 1 is greater than 10, yada yada yada. So that's simple. Another thing I forgot to note is one thing you have to do is you do want to write that each sample is independent. When we move on to the test statistic, you have to note this is another mistake people will make is they won't do a combine. They won't pool the data. You need to pool the proportion of p hat c, and that is done by total successes over total trials, or x1 plus x2 over n1 plus n2, and that will give you your pool. But you need to do that for the test statistics. You can't use the p hat 1, p hat 2 for your standard deviation. So when you move on to test statistic, it's going to be p hat 1 minus p hat 2 divided by p hat c times 1 minus p hat c over n1. These are separate fractions. It's just a little mistake I made there. So p hat c times 1 minus p hat c over n1, so a separate fraction, plus p hat c times 1 minus p hat c over n2. You can pull this out if you want to do some algebra, but this is what it is, and that should give you a z. And we get a p with that, and it means so fail to reject or reject depending on what p and what your significance is, and it means there's a difference in proportions, and you give a context. So a quick example is one college A, college B, survey yes or no question, 50 samples, NA equals 50, NB equals 50, XA equals 10, let's just say XB equals 20. So we have these two proportions. We're going to make this quick, and I'm going to do this on the calculator to show you. And so you want to go to calculator, you go to stat, tests, 2 proportion z-test right there, and I can type in x1, so x1 is 10, n1 is 50 for both of them, so x2 is 20, 50, and now I'm doing this, so I'll click this button, and it'll do everything for you, so it'll pool it, all that, so you don't need to spend the time pooling data and wasting your time. It'll give you all you need. It's right here, the p hat, right there, that's the pooled. And so you have a z, a p of 0.029, and everything else is given to us. So we just write that down. So quickly, p equals 0.039. You do need to write the formula. So write the formula. Show work of how you got your p hat c and how you got your p hat 1, p hat 2. So show work on how you got these. That's another mistake people will make. So just all you need to do is write that and this. And another thing is, if you want extra practice on this, the FRQ is 2012 number 4. That's a good one that I found. Again, just a quick recap. You want set up your hypothesis, conditions, random, independent, sampling distribution normal. Combine your p hat. Make sure you do that. Here's the sample. It's pretty much on your formula sheet, so you don't have to worry too much about that. Write your p, fail to reject, difference in proportion. There's a significant difference in proportions in this context. Give some context. Make sure you show your work for when you get your proportions, even for the combined proportions. Good luck on the A/B test.